Kodiaks, welcome to part 4 on our series on chemical reactions, decomposition reactions. The first reaction I'm going to do involves copper carbonate. When you heat it, it will decompose into copper oxide and carbon dioxide. The test that we're going to do for carbon dioxide involves taking a burning splint and putting it into the gas that's being emitted, and if that gas is carbon dioxide, then it will not support a flame. The flame will go out. So we're going to go ahead and heat this. Notice that it has a greenish gray sort of color, but as it gets heated, and you also want to heat things in test tubes kind of gently as you go, and you'll see them rise with the heat and then fall back down. So as that starts to rise, take it out of the flame, and as we heat it, heat it back and forth in the flame and get a nice color change going. Then what I will do is get a flame burning on this splint, and then if I put it in the test tube, it will extinguish the flame because of the carbon dioxide being produced. So if I try that again and take the burning splint, put it into the flame, or even just above it where the carbon dioxide is being produced, it's going to take that flame that's burning out here in the oxygen and put it where the carbon dioxide is being produced, and it will put the flame out. So there is reaction 1, decomposition of copper carbonate. For reaction 2, I'm going to use a catalyst to decompose carbon dioxide. Or not carbon dioxide, but to decompose hydrogen peroxide, too many oxides. And that reaction will be happening in the test tube right here. And you should be able to see, you'll be able to see bubbles forming when I add the catalyst, and we'll test to see whether or not those bubbles are oxygen by taking a burning splint and blowing it out until it is glowing. And then when it's glowing, we'll put it in the mouth of the test tube where the gas is being produced, and a glowing splint can reignite in oxygen, or at least it won't go out. So I'll go ahead and add a few drops of the catalyst, and we should start to see some bubbles forming. There we go. Takes a little while for the reaction to get going, but now that we have those bubbles forming quite nicely, a little bit of a color change, but that's just from the iodine in the potassium iodide. Then I will get a splint burning nicely, then I'll blow it out while it's still glowing, put it in here, and if we're lucky, if we get enough oxygen being produced, we can get that glowing splint to at least, well, we'll have to maybe try it a couple more times, a little bit more of the catalyst in there to get a little more oxygen being produced. And we're going to take our glowing splint and see if we can't get this reaction to work. There it goes. I don't know if you saw it, but it reignited. I'll blow it out and then take the glowing splint and put it back in there where the oxygen is, and it, when it gets close to the oxygen, actually will reignite. I'm going to get a little bit longer glowing splint here as that reaction is still happening. And here the splint is burning. I'll blow it out where it's glowing, put the glowing splint in with the oxygen, and there, as it gets to the oxygen that's being produced, hopefully you can see it reignite and glow. There we go. And so the oxygen is supporting that flame even though there's some moisture in there. So now you can really see it going. So flame burning, blowing it out, putting it in, and there's our positive test for oxygen gas. So two different decomposition reactions, one producing carbon dioxide, which will not support fire or combustion of the wooden splint, and the other one producing oxygen that does. Until next time, thanks Kodiaks, bye.